Hello, welcome back to part 4 of the week 7 of ECE 9013 course. In this part, we will be discussing the concept of hierarchy in classes and the concept of class inheritance. So for example, we can define a general class, for example, of people, and then within that class define a subclass which is student. Similarly, we can define a general class called animal, and then based on that define some subclasses called cat and rabbit. So the parent class is what we call the superclass. So for example, we can have animal as this parent class or superclass, person is a subclass, cat is another subclass, and rabbit is another subclass. And then student is a subclass of the person class. So the child class or the subclass inherits all the data and behaviors of parent classes. We can also add more information, add more behavior, or actually even override some behavior. So for example, we can define the parent class animal to be an object. So everything is an object. We initialize it with age and name, for example. We define the getter functions, get age and get name. Define the setter methods or functions, which are set age and set name. And then finally the double underscore str double underscore method, which is basically how the print or what appears on the screen when we run the print command. Now, to define a subclass, we can define a new class called cat, who is a subclass of the parent class animal. So in this case, the cat class inherits all the attributes of animal, which are the initialize in terms of age and name, the get age, get name, set age, and set name methods, as well as the str method. We also can add some additional functionality or methods that are specific to this subclass, like for example the method speak, in which we would print out the word meow, which is the sound of a cat. And we can actually even override the print method. So in this case, if the object or instance that we're calling belongs to the cat class, it would print out a different output if it were when compared to if it was an animal class. So here we added a new functionality with the speak method. The instance type of type cat can be called with new methods. Instance of type animal throws an error if we called one of cat's new methods. Note that in this case, the init method is not missing, but rather it uses the init method from the animal class. So, which method to use? A subclass can have methods with the same name as the superclass. For an instance of a class, we look for a method name in the current class definition. If it's not found, that's when we look for the method name in the parent class, or in the hierarchy, in the parent, the grandparent, and so on. So we use the first method up in the hierarchy that we find with that method name. So for example, here we define a subclass person belonging to the parent class animal. We define its own initialize method using the animal initialize, or we call the initialize of the animal class. And then we use the set name method also from the animal class. And we also define an additional attribute, which is friends. Then we add new methods such as the getter method, which is get friends, or we also can define a new method called add friend, which adds to the list. we define the speak method and calculate, for example, the age difference and also the print method. Here, for example, we can also import classes or import methods from particular classes. So for example, with this command, we actually bring in all the methods from the random class. Here we define a new class to be student belonging to the person class. Again, we can define a new initialize that is based on the initialize method of the person class, and also define a new data attribute, which is the major. Then we can define new methods such as change major, speak, and the str method. So note that we can actually even define class variables, and these variables or the value of these variables are shared between all instances of a class. So for example, if we define a class rabbit to be a subclass or a child class of the parent class animal, and define a variable called tag with a value of 1, and then we're defining an initialize method. Here, for example, we can define a attribute which is red to be the value of rabbit.tag, and then increment it by 1. So if we do this, it actually increments the class variable and changes it for all instances that may reference it. Here, for example, we are defining this tag to give a unique ID to each new rabbit instance. So the idea is whenever we initialize a new instance of the rabbit class, we add the tag by 1 as a kind of counter, for example. Again, here we can define new getter methods for that particular subclass, such as, for example, get the rabbit ID, or get the parent 1, or get the parent 2. So all of these are methods to actually build on methods from the parent or grandparent classes. Here again, we can define what the add function means for that particular class. So for example, in this case, we define the initialization of rabbit to be the age, and then the parent 1 and parent 2. We can define what the plus operator between two rabbit instances means. For example, what something like this would do if we define R1 and R2 to be instances of rabbit. We can say that R4 is a new rabbit instance with age 0, and R4 has a self as one parent and other as the other parent. And in this case, in the initialize operation or method, parent 1 and parent 2 are of type rabbit. We can also define some comparison methods for that particular class. So for example, in this case, decide whether two rabbits are equal if they have the same two parents. So we check if self.parent1 ID is equal to other parent1 ID, and if parent2 ID is the same for the self and the other, and the opposite to be if parent 2 is the same as parent 1 and vice versa, and we return whether parents same or parents opposite. And we are basically comparing the IDs of the parents, since as we mentioned, based on the definition, the IDs are unique. Note that we cannot compare objects directly. So for example, we cannot compare self.parent1 with other.parent1, but rather we are comparing an attribute, a data attribute. So as a conclusion for this week's lecture, object-oriented programming allows us to bundle together objects that share common attributes and common procedures that can operate on these attributes. We use the notation or the concept of abstraction to make a distinction between how to implement an object versus how to use the object. We build layers of object abstractions that inherit behaviors from other classes of objects. We can create our own classes of objects on top of Python's basic classes. Object-oriented programming allows us to create our own collections of data, organize information, divide the work and modularize it, access the information in a consistent manner, add layers of complexity, and similar to functions, classes are also mechanisms for decomposition and abstraction in programming. Thank you.